Hello, we are the Healthcare Through Play team, and my name is Matt Birchman. I am excited to talk to you about our senior design project. Currently, millions of people across the United States are affected by osteoarthritis. It is proven that rehabilitation methods can assist in the management of these conditions. After performing surveys in the first semester of senior design, we found 75% of people do not fully complete their rehabilitation. We discovered that this was due to the monotony of the exercises. This information inspired us to design a rehabilitation ball that senses the pressure you place on resistors. In turn, it converts the information gathered from the hardware, which implements a game that motivates users to complete their exercises and gather data for physical therapists. A more comprehensive overview of our device will be discussed later in the presentation. It was important for us to talk to professionals in the field that are potential stakeholders. We spoke with two professors in bioengineering from Anschutz Medical Center, Robert Shandis and Richard Weir. They were instrumental in the design of our project. Major feedback we received from these professors included structural design, robustness of the device, and displaying the electrical output of a hardware. The objectives we met as a team included having multiple working prototypes that address the feedback of our customers. We invented a device that uses data gathered by the hardware and implements multiple games that users can interact with on a computer screen. We use silicon to protect the sensors and have P-Spice models to show our electrical output of the device.
Hello, my name is Ova and I'm here to talk about our budget as well as our design method throughout the last 2 semesters. Our total budget for this entire project put us at $722.61 out of the allotted $800. Here are some of our more notable purchases that we make this semester. After a lot of consideration, we bought an Elgo Mars 3D printer for $230. We also bought new force-sensitive resistors and standard wires around $30. We use many different design processes and methods for our hand rehabilitation device. In the beginning of our project, one of the design methods we use is to create a mind map. A mind map is a graphical way to represent ideas and concepts. As a team, we brainstorm about 30 to 50 different ideas.
Hello everybody, I'm David Trujillo with the Healthcare Through Play Senior Design Group here at CU Denver. And today I'm going to go ahead and show you our physical prototype for the project that we've been working on. Here you can see the first iteration of our project. It's a modified can-do stress ball, and we went ahead and attached these force sensing resistors to it. These go ahead and register how hard you're squeezing, and they send it to this Arduino here. This Arduino works as the brain of the project and sends all the data to the secondary receiving Arduino here. This Arduino is connected to your PC, and it's what interfaces the game from the prototype. This prototype is wireless, and it utilizes this 2 battery packs in order to power itself. This is the secondary iteration of our project. After talking to Dr. Richard Weir at the Anschutz campus, we were informed that the egg shape is actually the most beneficial when it comes to hand rehabilitation through stress ball therapy. So we went ahead and modeled our project after an egg and 3D printed this design and covered it in silicone padding. We utilized the same sensors from the first prototype in this design.
Hello, my name is Tiffany Chang, and now I will be talking about the components that we use for the prototype and also demonstrate the game portion. Our circuit for a hand rehabilitation device utilizes an active low-pass RC filter that filters out most noises that are caused by microcontacts. The low-pass RC filter will clean up and reduce noise when contact is made with the force-sensitive resistors. Based on our P-Spice simulations, we used resistors with values of 100 k ohms, 2 k ohms, and a capacitor of 47 picofarads to build our circuit. As less pressure is applied to the ball, the voltage decreases. Now moving on to the game portion. As you squeeze the ball, the bird will continue to move forward in the game. The speed that the bird ascends at depends on how hard you squeeze the ball. As you squeeze lightly, the bird will not fly as high. As you squeeze harder on the ball, the bird will fly even higher. The total sum of how high the bird goes is based on the total force exerted onto the sensors on the ball. If I try squeezing it with just my pinky, the bird will not go as high. We hope you enjoyed our video. This sums up the healthcare team's hand rehabilitation prototype and senior design project for fall 2019 and spring of 2020. Thank you so much and have a great summer.